Hi all, welcome to cz.com. Here in this video we will learn about the ionic bond or the electrovalent bond. As we know that an ionic bond or an electrovalent bond is formed by the transfer of electron, right? So there's a transfer of an electron from an atom A to the atom B, correct? Let's take here an example of the sodium chloride. I'm going to explain the ionic bond formation, with the example of sodium chloride, because sodium chloride is the most common ionic compound. And here, what happens here? Sodium with the atomic number 11, its electronic configuration actually is 1s2, 2s2, 2p6, and 3s1. Now sodium here, it has a 1 electron in the valence shell. It can gain the nearest noble gas electronic configuration, which actually for the sodium is neon with atomic number 10. So it can gain the nearest noble gas electronic configuration by the loss of electron. So that's why when there is a loss of an electron, right, from the sodium, what do you get? You get the sodium cation. Sodium with a positive charge, and here this sodium ion has a 1 electron less, right, that you find here in the neutral sodium atom. That means its electronic configuration will be 1s2, 2s2, 2p6. That will be the electronic configuration of sodium ion, and that is actually the electronic configuration of the neon with the atomic number 10. So when sodium it loses electron, the same electron it will be accepted by the chlorine here, right? Why? Because chlorine there has an atomic number of 17 and its electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p5. So in the valence shell here for the chlorine, it has 3p5, and the nearest noble gas to the chlorine is argon. For the chlorine it is argon, and argon has a 3p6 electronic configuration. That means chlorine, it needs 1 more electron and it will form Cl negative, and the Cl negative it will have electronic configuration of 1s2, 2s2, 2p5, 3s2, 3p6. So that is the electronic configuration of a neon. Now when you get the two ions here, we got the cation here, the ion with the positive charge, and here the anion with the negative charge. Now these ions, they come close together, and the force of attraction between the two ions, it will pull them together, and they will come close and form a crystalline solid. Okay, these ions will form NaCl, so you get a crystalline solid. Because most of the ionic compounds are crystalline solids, the reason because the force of attraction which is there between those ions, which holds the ions together in the crystalline solid, that is pretty strong. Okay, the force of attraction is very strong. So that means for an ionic bond we need an element that can lose electron, and we know only metals have a lower ionization energy. So for the ionic bond formation, for the transfer of an electron, we have to take one of the element as a metal, because metals can lose electrons easily. So that is the number 1 point. Correct? We should have an element with a lower ionization energy. So the ionization energy should be less. Correct? Sodium can lose electron by absorbing very small amount of energy. So it has a very, very low ionization energy. That means there should be an element that can easily lose an electron, and only metals can lose electrons easily. Second condition for the ionic bond formation is that we should have an element that can gain electron, that has a high tendency to gain the electron, right? And only the non-metals, we know the non-metals, right, over here, non-metals, they gain the electron, they have the high tendency for the gain of electron. So that means you get an ionic bond only when you react a metal with a non-metal, correct? When you react a metal with a non-metal, only then ionic bond is possible. Ionic bond cannot be possible between the two non-metals, between suppose chlorine and the bromine, oxygen and the sulfur, carbon and oxygen. They cannot form the ionic bond, because we need a one metal, other one non-metal. Why? Because we need a one atom that can lose electron, the other one that can gain electron, and that is only possible when you react a metal with a non-metal. Two metals cannot form the ionic bond, two non-metals cannot form the ionic bond. It's only possible when you react a metal with a non-metal, because only then the transfer of electron can take place. Right, so that means the two conditions are that we should have an element with a low ionization energy. The second one is that other element should have a high tendency to gain the electron. It should have a high electron affinity actually, correct? And when the ions are formed, another energy involvement is there. That is, when the gaseous cations and the gaseous anions, right? When these ions come close and they form the crystalline solid, due to the attraction, there is some energy loss. Energy is released here, and that energy is called as lattice energy. Okay, that is a lattice energy. This is very important, the lattice energy point, because here with the lattice energy we can explain the stability of the ionic compounds. So that means, let's conclude here what we have learned. Ionic bond formation takes place when you have an element that has a low ionization energy that can easily lose electron, and you should have an element that has a high electron affinity as well, correct? And here you can see the first step is an endothermic step. This is the endothermic step. Absorbed here, energy is absorbed, because when sodium, right, it absorbs energy which is called as a ionization energy, and then it can lose the electron. Obviously we know the sodium, it loses electron easily. That means it will gain very small amount of energy, correct? And then it will lose the electron. So that means here the energy involvement is called as an ionization energy. So the first condition is that we should have a lower ionization energy, okay, lower ionization energy. And this step here is an endothermic step. You have to supply the heat here. The second point is another element should be there that can gain the electron, right? That, like we have a chlorine, when it accepts electron, okay, so it releases some energy, correct? It releases some energy when it forms a Cl negative there, and that's called as an electron affinity. And this element should have a high electron affinity, right? That means it should attract the electron very strongly. So the second point is that you should have a high electron affinity, and you can see here this is an exothermic step. The second step is an exothermic step. Third and the last one here is that you should have a high lattice energy. When these ions are formed now, Na plus and you got the Cl negative, they form the sodium chloride, NaCl. They form a crystalline solid. Okay, these are solids generally, and then when ions come close and form the crystalline solid, they release some energy which is called as a lattice energy, and this is also exothermic step. And this should also be the high, correct? You should have a high lattice energy. Okay, this is exothermic step, so that means it should be very stable. Ionic compounds, while you find lattice energy is very strong, that means the ions are very strongly held together. When the lattice energy is high, so the ions are very strongly held together. There are lots of applications, right? We can explain so many things with the lattice energy. Many properties of the ionic compounds you can explain only with the help of lattice energy. That we will discuss in our next video, right? So that means so far we have studied that ionic bond is formed only when you react a metal with a non-metal, because for the transfer of an electron you should have an element that can easily lose electron, and you should have an element that can easily gain electron. And when the ions are formed, now those cations and anions, they come close and they form the crystalline solid. And the energy released, which is there when 1 mole of a ionic compound is formed, right? That's called as a lattice energy. Hope you got the concept. Thanks for watching the video. Bye for now.